Do you want to go to Hogwarts? If you do, you'll have to walk through a brick wall between platforms 9 and 10 at King's Cross Station. But it is possible, and it's with quantum tunneling. In classical physics, if an object has less energy than a barrier, then it can't cross it. So if I throw this ball at a wall, it'll bounce back. But in quantum physics, the physics used for describing very small things get a little strange. If I throw an electron at a wall, for example, there's a chance that the electron just passes or tunnels right through the barrier and appears on the other side. So let me explain. On the quantum level, matter starts behaving more like a wave. And waves can exist in many places at the same time. According to the Copenhagen interpretation, the quantum object is then said to be in a superposition of states. This means that the particle has a certain probability of being found in each place. But the probability isn't equal across all locations, it rather appears as an oscillating wave function. However, as soon as the particle is observed, all the possible locations of the particle collapse into a single point. Think of the probability wave as an imprecise GPS device that you're using to try to find your lost pet electron, Max. You don't know where Max is within the range of possibilities, but you do know that it's more likely that he's going to be here than there. So what happens when this probability wave approaches a barrier? According to Schrödinger's equation, the probability of the particle being found on the other side of the barrier decreases exponentially with the width of the barrier, but never quite reaches zero. Note that no tunneling actually happens. The particle doesn't move through the barrier. There's just always a slight chance that the particle might exist on the other side of the barrier, so sometimes it does. It's like if you saw Max's GPS tracker approach a river. He isn't able to cross it, but when you go check, you find him across it. How? The range of possibilities for his position allows him to be across the river, so sometimes he is. This may seem like just a theoretical phenomenon, but it actually plays a huge part in many everyday occurrences. For example, quantum tunneling is how positively charged atoms in the sun can overcome their electric propulsion and fuse into helium, releasing energy that fuels the sun. Okay, so let's take you back to King's Cross Station. Schrödinger's equation from before tells us the probability that an object will tunnel through a barrier. And we get that the probability will be 1 over e to the 10th to the 35th.
You're telling me there's a chance?
The universe will probably end before it happens, but yeah, it is possible.
Yeah!